Okay, let's go ahead and talk about a weighted mean. A weighted mean is similar to the mean of a discrete probability distribution, but instead of using the probabilities, we use the frequencies to calculate it. So, for example, this is how a grade point, your GPA is calculated. So, this is a very important problem to know because it's always good to know how to calculate your GPA. I realize that there are GPA calculators online nowadays, but it's still a good thing to know. So Stacy's grades for last semester were A, C, D, B, and A. The courses were 3, 3, 4, 2, and 2 credit hours respectively. Note that an A equals 4 points, a B is 3, a C is 2, a D is 1, and an F is 0 points. Calculate Stacy's GPA for last semester. So first what we do is write the letter grade down. A, B, oops, I should write the letters she earned down. So it's A, C, D, B, and A. Now let's change those letter grades to points because remember, we cannot average qualitative data, and a letter grade is categorical or qualitative data. So we need to change that to numbers so we can find the mean. So an A is 4, a C is 2, D is 1, B is 3, and another A is 4 points. These are going to be our random variable X. Now, the credit hours are the frequency. And respectively, the courses were 3 credit hours, 3 credit hours, 4, 2, and 2. Now, here's how we calculate the GPA. We take the points and we multiply by the credit hours. So 4 times 3 is 12. 2 times 3 is 6. 1 times 4 is 4. 3 times 2 is 6. And 4 times 2 is 8. So we add all of those up. So if we add those up, we get a total of 12 and 6 is 22, and 4 is 26, and 6 is 12 and 6. 12 and 6 is 18. Wow. 18, 22, 28, and 8 is 36. So we have 36. Then we add up the credit hours, the frequency. So if we add those up, so we added there, we added here, 6, 10, 14. So how do we calculate the GPA? The GPA is the points times the credit hours divided by the total of the frequency or the total credit hours. So we have 36 over 14, which gives us a GPA of 2.57. So that's how you find your GPA. Now, we could do this in the calculator. We would put the credit hours in list 2, and we would put the X in L1, and we would do the one-var stats just like we did in the previous video with L1 in list and L2 in the frequency list, and it would give us a mean of 2.57, which would be the GPA. Okay, let's talk about how we interpret the mean of a discrete random variable as an expected value. So, because the mean of a random variable represents what we would expect to happen in the long run, remember, meaning we have to do lots and lots of experiments, the mean is also called the expected value. So if you see expected value, say to yourself, oh, I'm just finding the mean, no big deal. So let's look at this problem. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose an 18-year-old male buys a $250,000 one-year term life insurance policy for $350. According to the National Vital Statistics Report, Volume 58, Number 21, the probability that the male will survive the year is 0.998937. So that's the probability he lives. Compute and interpret the expected value of this policy to the insurance company. So first we need to make a probability distribution. So we have X, which in this case is the profit to the insurance company. And we also have the probabilities of those profits. So there's two options, right? Either the person that bought the policy lives or the person that bought the policy dies. So what happens if the person lives? Well, if they live, the insurance company makes $350, which is what that person paid them. And the probability of that, according to the problem, is 0.998937. What happens if the person dies? Well, if the person dies, then the insurance company has to pay out $250,000. But remember, the person that died already gave the insurance company $350. So what really happens is if we take the $350 the insurance company took in and subtract the amount they have to pay out, we get negative $249,650. So if the person dies, the insurance company loses, so it's a negative number, $249,650. Now, how do we know the probability that the person dies? Well, you've either got two options, right? Living or dying. So dying is the complement of living. So remember, the complement rule says we take 1 and we subtract the probability we know, in this case living, and that gives us the probability of the complement, which in this case is dying. So there's our probability distribution for the discrete random variable of the insurance company's profit or expected value. And now we need to find the mean. So we can do that by putting the X variable, random variable, the profit in our list 1, and the probabilities in list 2, and doing 1 var stats. And when we do that, we'll come out with a mean of the random variable as being $84.25. So this is how insurance works. All insurance works this way, including health insurance. They take the probability you get sick versus the probability you stay well. They determine how much they're going to have to charge people to make money. If you notice, in the long run, they're making $84.25 off every person every year. So that's because most people live. So how would we interpret this? We interpret this by saying the company expects, remember this is an expected value, to profit $84.25 for each 18-year-old male, because that's what type of people we were talking about, client it insures. Now remember, I cannot stress this enough. This is an average profit when a large number of clients are insured. So that's why insurance companies want to insure more and more people. Now, not to get political, but just to explain something, the Affordable Care Act had what they called the individual mandate in it until it was struck down by the courts. Why did they do that? Well, they required the insurance companies to give insurance to people with pre-existing conditions. If you have a pre-existing condition, you're more likely to spend more money at the doctor's office, and so the insurance company loses more money on you. So before the Affordable Care Act, they made people with pre-existing conditions, either they could not get insurance or it was extremely expensive for people. In order to cut the cost for people with pre-existing conditions, they made the individual mandate, which said everybody had to purchase insurance. Why? Well, that forced healthy people to buy insurance, which helped pay for the people that did not have insurance. I'm not arguing for it, against it, whether it was good, whether it was bad, but that's what it was, and that's why they did it. So this is a good reason, and another great example of how probability and statistics is relevant every day in our lives, whether we know it or not. And we will pick up with some more in the next video.